Now, it's my pleasure to introduce our presenter for today, Dr. Brett Bruin, the EMEA Scientific Affairs Manager for IDEXX. Dr. Bruin has been working in the field of microbiology for over 2 decades and has over 25 years' experience in the analysis of water for the presence of waterborne pathogens. He's worked closely with laboratories and experts around the world, developing new technologies, training analysts, and establishing best practice in order to optimize complex technical procedures and generate robust methodologies. Welcome, Brett.
Thank you, Nigel. I'd just like to take this opportunity to extend my welcome to everybody that's joined us today. We understand you have busy schedules, so you taking time out to join us is very, very much appreciated. So I'm going to talk today about IDEXX Tecta, which is a novel, rapid, automated testing system for total coliforms, including E. coli, and also enterococci. The great thing about Tecta is that it can be used by anyone in multiple locations at any time. It's a great benefit of this system, as you will see. There are 2 instruments currently available. There's the Tecta B4, and with this you can run 4 current tests at a single temperature. It's got quite a small footprint, and it's ideal for mobile or remote testing. The additional offering, which is more flexible, is the Tecta B16, and this can run up to 16 concurrent tests at multiple temperatures, as you will come to see. Those tests can be conducted simultaneously. And one of the great advantages of the Tecta system is that it has a very, very wide dynamic range from 1 CFU up to 10 to the 8 CFU per 100 milliliters without any dilution being involved. There are 4 TectAlert cartridges currently available. There's TectAlert CCA for the analysis of water for total coliforms, including E. coli, and that's run at a temperature of 35 degrees C. In addition to that, there's a rapid E. coli test, TectAlert ECA, and this is run at an optimized temperature of 41.5 degrees C. In addition to that, we have TectAlert FCA for the analysis of fecal coliforms, which is still employed in some regions, and that is run at 44.5 degrees C in line with current reference methodology. And then finally, there's TectAlert ENA for the analysis of water for the presence of enterococci, and that is run at a temperature of 41.5 degrees C. The cartridges come in a standard format. There's obviously labeling on the top of the cartridge which contains your lot numbers. There's also space there for you to record sample IDs. There's a sterile evidence closure, so you can ensure that that cartridge has not been opened and the integrity is maintained. And then there's a tamper-proof closure that you can use once you've processed your sample. There's also a 100 milliliter fill line that's embossed onto the cartridge, so you don't need to use any measuring cylinders to measure the volume of your sample. The granular reagents and sodium thiosulfate are contained within that cartridge, and as long as the cartridge isn't compromised, they will remain stable within the device itself. The main body of the cartridge is made of polypropylene, and in addition to that, in the base of the cartridge, there's what we call a polymer partition element. It's very critical to the performance of the Tecta device, and we'll cover that in more detail in a short while. Some of you may be familiar with other IDEXX methodologies, such as ColiAlert 18, and the concept with Tecta is very, very similar indeed. So we have specific nutrient indicators that are catabolized by specific enzymes. So these enzymes will be specific to various target bacteria, whether that be total coliforms, E. coli. When those specific enzymes catabolize the nutrient indicator, they form various products. So just to give you an example, in the case of total coliforms, we have a nutrient indicator, anthracene galactoside. that is hydrolyzed by the enzyme beta-galactosidase, which is quite specific for the total coliform group. And we get the products galactose and hydroxyanthracene, and that fluoresces at a wavelength of 485 nanometers. In the case of Escherichia coli, we have a different nutrient indicator, pyrene glucuronide, and the enzyme beta-glucuronidase, which is quite specific for E. coli, hydrolyzes that nutrient indicator to form glucuronic acid and hydroxypyrene, which fluoresces at a wavelength of 385 nanometers. And this is where things get quite clever. So in their native form, the nutrient indicators are hydrophilic, and they will remain in solution within your water sample. In the presence of those specific enzymes, the products that are produced, the fluorescent products that are produced, become hydrophobic. That means they want to come out of solution, and this is where the cartridge design is very, very critical. If we look at the cartridge in the base, as we've already said, we have what we call the polymer partition element. And because the fluorescent products of enzyme activity are hydrophobic, they will migrate and accumulate within that polymer partition element. They accumulate over time, and the detector device is constantly checking the level of fluorescence within that polymer partition element. So it's very clever and very unique. If we think about this in terms of bacterial growth kinetics, the more bacteria we have initially within a sample, the more enzyme we're going to have present within those bacteria, the more substrate turnover we're going to have, and the more product will be produced. And then we'll get a more rapid accumulation of that fluorescent molecule within the polymer partition element, and therefore faster detection. This is the basic principle of bacterial growth kinetics. There are some other great advantages of the polymer partition element. Firstly, because we're using a spectrophotometer to detect that level of fluorescence, we're eliminating human interpretation. We're eliminating that subjectivity in sample analysis and result interpretation. Also, because of the way the detector is designed and because of this unique polymer partition element, sample color, turbidity, and levels of particulate matter within the sample do not impact test results. So a great advantage there. If we look at the results that we might get from detector, we can relate those back to bacterial growth curves. So on the left here, we have a typical bacterial growth curve. We're looking at the concentration of bacteria plotted against a function of time. And we have this typical shape, the lag phase, the exponential phase, stationary and death phase. We see a very, very similar trend with the detector device. So on the right, we have the fluorescence buildup within the polymer partition element plotted as a function of time. And again, you see a very similar curve. You see the lag phase and then an exponential buildup in the level of fluorescence over time, which then will taper out. Time to detection is extremely important to the function of the detector device. And again, it comes back to this concept of more bacteria, more enzyme, more product, faster accumulation, faster detection. So we see on the left here, we have these growth, these fluorescent curves as the fluorescent product builds up within the polymer partition element. The point at which the level of fluorescence increases above a defined threshold will indicate a positive detection of a specific target organism. The time at which that occurs is called the time to detection. This is a relative measure, and the time to detection, that relative measure, can be directly correlated to the estimated bacterial concentration. More bacteria, the faster the time to detection. Just to cover again some of the advantages of continuous monitoring, you can get total coliform E. coli results available within 2 and 18 hours. It's very much dependent on the concentration of bacteria in your initial sample, but you can get very, very rapid results in some cases. We have this very, very wide dynamic quantification range from 1 CFU up to 10 to the 8 CFU without dilution, and that is very unique. There's no other microbiological reference method that can currently cover that dynamic range. And again, in the majority of cases, no dilutions would be required. There is one caveat to that. If you are testing marine water samples, we still need to dilute at least 1 to 10 because the salt content in that marine water can affect the performance of the test itself. So that's the only caveat where dilutions are required. We also have something that's very unique in terms of data management. You get objective test reports for every single sample that is analysed. Those results are stored on the Tector device itself. They can be emailed to one or a number of analysts so that they can then act upon the results. They can be stored on external drives such as a USB stick. They can also be exported as a CFV attachment for integration into a LIMS system. So it's very objective, it's fully automated, and it's fully secure. So just pause a brief moment and then we're going to cover an operational demonstration of the Tector device itself. In the majority of cases, the Tector instrument, whether it's a B4 or a B16, can be installed almost anywhere. There are some limitations on that. Obviously, there are some height restrictions and space restrictions, depending on which device you are using. We also try and limit exposure to external heat sources, such as air conditioning units, which might affect the performance of the device itself. But very few limitations, can be installed almost anywhere. The great thing about Tector is it can be run by almost anyone. You need very, very little microbiological experience to perform an analysis using this device. The tests can be run at any time. They can be set up very late in the day and just run overnight. They can be set up prior to holidays or prior to weekends, and you can still get those results and act upon those results in real time because those results are emailed to the analysts as soon as they are available. All of the 4 cartridges that we've mentioned are available currently in a 100 milliliter format. That's fairly standard for the water industry. And we've covered the 4 different test types that we have available. In addition to that, you will also be supplied with what we call an optical validation. Something that we suggest is performed on a monthly basis, and it's called an optical validation. You're basically checking that the device is reading against the standard correctly. As we said, the B4 has a single incubation mantle. It can only be run at a single temperature. However, the B16 has 4 individual incubation mantles, and they can therefore run tests at different temperatures. There's one caveat there. You couldn't run a test at 35 degrees and 44.5 degrees in the same device because the temperature differential is too wide. But the majority of tests can be run at the same time. So, for example, you could run a total coliform test, an E. coli test, and an enterococcus test in the same device at the same time. The Tector, both the B4 and the B16, are continuously incubating and continuously monitoring each sample. And when that fluorescent signal is detected by the spectrophotometer, the instrument will immediately report that positive result to the user. Very, very simple to run. You would take the appropriate cartridge for the test that you wish to perform and break off that tamper-proof seal, open up the cartridge, and then you're just going to add your water sample to the 100 milliliter fill line, close the cartridge, and then you're gently swirling the sample to dissolve the reagent. Very, very analogous to what you would do with other existing IDEXX testing methodologies. Once that's done, you would add your sample information to the device. You would select the appropriate test type. In this case, we're looking at Tector CCA E. coli total coliform test. You would select the water type. In this case, it would be drinking water, but you can also select ambient water, such as rivers, lakes, or wastewater. And then you would press add, and a chamber will automatically be selected for you to use based upon that test type and other tests that are currently ongoing. You then open the Tector instrument, add the cartridge to the selected chamber, close the lid, and incubation and sample analysis starts automatically. You're completely hands-off after that point, and the sample analysis will just run in the background while you continue to do other things within your laboratory. The results are very, very simple to interpret. Screen that details the analyses which are ongoing. If you have a red icon, it means sample analysis is complete and the target has been detected. If you see a yellow icon, the sample analysis is currently ongoing. And if you see a green icon, sample analysis is complete and the target is not detected, so the sample is negative. You will have very, very detailed reports, so any sample IDs that you put in and any other parameters that you input into the device will be included on the report. And then finally, you'll be given your results for whatever test you have selected. So in this case, we have an E. coli result indicating present at 17 hours, 41 minutes, 19 seconds, and the estimated bacterial concentration is 1 CFU per 100 milliliters. For the total coliforms, we have a present result in 16 hours, 24 minutes, 20 seconds, and the estimated bacterial concentration is 15 CFU per 100 milliliters. Again, if you had a much higher concentration of bacteria, that time to detection would be much, much lower. In another example case here, we have an E. coli and a total coliform result as being absent, and the full elapsed time of 18 hours has been completed. Just a couple of general notes. No confirmation is required with this device. It's very, very similar to other IDEXX tests such as Codalert 18. They are considered confirmed methods. We do recommend that the optical validation is performed monthly, and that will typically take around 20 to 30 minutes to complete for 16 chambers. The validation cartridges should be certified after 2 years, and we do recommend that the samples are disposed of in accordance with your local guidelines, and very similarly to current testing that you would already perform within your laboratory. At that point, I'm going to hand back to Nigel for the second poll.
Okay, thank you, Brett. At this point, we would like to pause for a moment and hear from everyone again on the whole. A Tector could be of value to an organisation in many ways. Please take a moment and let us know if you see any potential uses for Tector in your operation. Please select all that apply and click the submit button at the bottom of your screen. And while we wait for other people to complete the survey, I wanted to remind you to please enter any questions you might have in the Q&A tab, please. So we'll just wait a moment for those responses to come in. It's building. Okay, hopefully everyone has had enough time to respond to the poll. Let's have a look at the results. So The majority of people, let's say 25 people, are saying remote analysis is the most interesting application. Evening and weekend testing is another one that's of interest. Construction or emergency testing is the next one. To test for recreational water, to address staffing challenges, wastewater, biosolids, another. So that's very interesting feedback. Thank you. All right, so thank you for taking time to provide your input into our poll. I'll turn you back now to Brett to discuss real-world applications of Tecta. Thank you.
Thanks again, Nigel. Yeah, we did want to cover some real-world applications and give a few case studies that we've experienced in the last few years. Obviously, we all live in the real world. We understand that water networks are extremely complicated. They involve a lot of infrastructure, and things often happen to that infrastructure. There are mains breaks, breaks in pipes. Also, networks need to be upgraded at times or even extended at times. And this all costs a lot of money. If you can reduce the amount of time that a network is out of commission, even by 1 or 2 days, you can make significant savings in terms of resource, but also costs. So by using the Tecta to reduce that time to detection, you can significantly reduce costs associated with construction or emergency sampling. One thing to certainly mention here is that typically samples are taken and sent to reference laboratories for analysis, and that can take a significant amount of time, certainly several days before results are reported. By using the detector, either in a reference laboratory or at the location itself, you can significantly reduce that time to a positive or indeed a negative result, and also significantly reduce the costs associated with bringing a network back into commission. The second scenario that we have are evening, weekends and holiday testing. Again, it costs money to bring in analysts over holidays or over weekends. But in addition to that, it's also inconvenienced people and using up their time and resources. So samples that often come in before a weekend or before a holiday might have to be refrigerated. That could also be in breach of guidelines for sample analysis. With the Tecta, that doesn't matter. If a sample comes in late in the day or before a holiday, you can still very, very quickly set that sample up, start the machine running, and you will still get those results in real time and be able to act upon those results in real time without the analyst physically having to be present within the laboratory. Another scenario we've seen is trying to streamline operations. Often samples are taken from a very, very wide geographical area, and they often have to be shipped or transported to a central location, which may be many, many miles away from some of those sampling points. By using the Tecta, because of its small footprint, you can actually set up very centralized analytical laboratories and streamline operations and reduce the amount of time it takes for those samples to get to the laboratory and for the results to be produced. A further scenario is regard to recreational water testing. So this could be rivers or beaches where closures mean a reduce in revenue. It's an inconvenience to bathers. It's also an inconvenience to the local communities. In these scenarios, samples again have to be taken and shipped, often long distances, to reference laboratories for analysis. By using the Tecta, you can have very, very localized resources samples can be taken, they can be analysed very, very quickly, and the results can be produced, reducing the amount of time that a beach or a recreational spot is closed, but also ensuring that the water is safe for recreational activities such as swimming or yachting or kayaking. Furthermore, we can use detector to improve operational efficiencies. There are numerous wastewater treatment plants all over our various locations. Samples have to be taken to ensure that those facilities are operating efficiently and efficaciously. Samples have to be taken when influent comes into the plant and during the various treatment processes, and also the effluent leaving the plant. All of those samples currently have to go to centralized laboratories for analysis. With Detector, you can actually bring that analysis capability onto the site, onto the wastewater treatment plant, and the operators in the treatment plant can run the analysis there. So they're saving time in shipping, they're saving costs in shipping, they're also getting the results much more rapidly, much more efficiently, and then they can act effectively to ensure that that treatment plant is operating at maximum efficiency. Complex matrices can often cause problems, particularly with traditional microbiological methods, and particularly those methods that involve membrane filtration. Any matrix that has significant color, significant suspended solids is going to cause issues with membrane filtration. However, with the detector device, because of the way it's designed, because of the way the cartridges are designed with the polymer partition element, color and particulate have limited impact on the performance of the test. So we can reduce subjectivity, reduce analytical error associated with those types of samples without performing huge dilutions, which would be necessary with some of the traditional methods currently in use. And then finally, we can look at a scenario where we have very, very remote locations, and by remote I mean things like mines, maybe military installations that might be moving on occasion, cruise ships. With regards to cruise ships, those samples are essential to ensure the water quality for all of the passengers and the crew on board, but they can currently only be taken and analysed when that ship is in port. With Detector, because of its small footprint, you could easily set up a small microbiological laboratory on the ship itself and analyse those samples, get those results in real time, and perform any remedial actions in real time. So hard to reach locations is again another excellent benefit of using the Detector device. Did just want to give you 3 actual documented examples of where the Detector is being currently employed around the world. So, example number 1 with regards to remote analysis. And in this situation, a very remote community in Canada has an absolute legal requirement to test its drinking water to ensure it's potable for its residents. But at the time, they were shipping samples, often by plane, very, very long distances to a reference laboratory. There were no laboratory facilities available in the locale. They're not trained microbiologists that live within this population, and they need the results as quickly as possible. And if you can imagine taking samples, shipping them by air to a reference laboratory, waiting for those results, you're looking at several days before you know that the water is safe to drink. The solution that we gave them was to install a Tector B16 at the location and have the local population analyse their own water samples. We did perform some trials with them. They were performed in 2 phases. In phase 1, they took 10 artificially contaminated samples and 10 naturally contaminated samples and compared the analysis using the Tector B16 and Colilert 18. The results from the first phase of that trial showed that the methods were both in agreement. And we're currently using this in presence-absence format because the limit for drinking water is 0 CFU per 100 millilitres. In the second phase of the trial, they looked at naturally contaminated samples, and they took around 60 of those and again compared the analysis using Tector to analysis at a reference laboratory using Colilert 18. 8 of those 58 samples tested positive, and the results between the Tector agreed with the results from the reference laboratory. So it's a huge benefit to this remote community. They're saving resources, they're saving costs, they're saving time in getting those results and ensuring that the water that they have, their drinking water, is potable and suitable for them to drink. Our second scenario is looking at wastewater analysis. So we all know that wastewater analysis can potentially be problematic. We're often having to make very significant dilutions of the water sample, and each time we introduce a dilution, that's beginning to introduce bias and error into the results that we see. We have often very wide ranges of bacterial concentration within wastewater. We often have colour, turbidity, suspended solids within those samples. So again, using traditional methodologies, it's very difficult to analyse this problematic matrix. The solution we proposed was to use the Tector device to analyse wastewater without dilution. So in this trial, the laboratory looked at wastewater samples for the presence of both E. coli and also fecal coliforms. The wastewater samples were spiked with a secondary effluent at a range of concentrations. So we're trying to test that dynamic range from very low levels up to these very high levels. And for the 2 different methods, the E. coli, we're comparing Tector to US EPA method 1603, and for fecal coliforms, we're looking at comparing Tector to APHA 922D. And also from that data that was generated in this trial, we were able to establish a number of categorical performance characteristics, which we would typically look at when we're comparing microbiological methods. So we can see the data generated across that dynamic range from your low levels up to about 100,000 CFU per 100 millilitres. And there's really nice concordance there between the results between the Tector and between the membrane filtration methodologies. You can also look at some of these categorical performance characteristics, and they're quite impressive. And when we look at levels of sensitivity for E. coli at 100%, 98.7% for fecal coliforms, specificity levels are greater than 90% for both of those parameters. These are in line with what are currently specified within documents such as ISO 13843, where we're looking at greater than 90% sensitivity and specificity. The concordance rates between the 2 methods that were compared are very high, greater than 95% in both cases. And the false positive rates and false negative rates are very low and are typically in line with what we would expect for current reference microbiological methods. So very nice results and a real advantage because, again, we don't have to perform those wide dilutions with this very complex matrix. Final scenario is looking at biosolids. We're generating biosolids in huge amounts all of the time. And quite correctly, we use those biosolids, particularly in agriculture, and particularly for use in food crops that are used to feed animals. Obviously, we have to test that matrix to ensure that there's some treatment being applied and levels of specific indicators, such as E. coli, have been reduced to safe levels. The problem with biosolids is, again, we have this very, very wide range of bacterial concentration within that matrix. We have significant levels of interferences within that, and very, very significant levels of particulate within the sample. So the solution, again, that we proposed was the vector to analyze those biosolids samples. So we performed some analysis of biosolids for the E. coli, and we're using a very standardized methodology that is currently used with traditional methods. So we take 1 gram of the biosolids and add that to a 99 milliliter sample of sterile water, and then take 0.1 milliliters of that suspension and add it to 100 milliliters of sterile water. There are dilutions in there, obviously, but this is a standardized method for used with biosolids. The analysis between Tector and co-alert team was compared, and approximately 50 samples were analysed during this trial. The results were very, very good, and the concordance between the results was very satisfactory. What we're seeing here in this case for E. coli is that about 95% of the results are within 0.7 logs of the reference method. And we are interested in logs here because we're looking at log reduction of the levels of E. coli in the biosolids to ensure that the treatment has been appropriately applied and that the levels of E. coli are up to a safe level before it's used in the application, agriculture in this case. The great thing here is that the time to detection was significantly lower than using a reference method. So it was a mean of 8.7 hours to get a positive result for those samples. And that's saving a whole lot of time for the biosolids facility. They don't have to ship their samples out to a reference laboratory. They don't have to wait a week to get those results, and they can turn over the biosolids in a much, much more rapid fashion. So we're about coming to the end of the presentation. I did just want to go through a few conclusions. So the Tector is novel. It's fully automated, rapid. It can be used on site. Detection is still based on proven technology, enzyme substrate reactions. The quantification is based upon principles of growth kinetics. And this advanced polymer partition technology overcomes some of the limitations we have with color, turbidity, and other interferences. The automated read of the Tector is of great benefit because it's eliminating subjectivity and potential human error. You have improved data management. You're not having to record data in Excel files or bits of paper. You can just receive the emails. Everything is stored on the device. Tector is very, very complementary to existing IDEXX offerings. So you have multiple solutions for multiple situations. It is a self-contained lab in a box, but that's great because it means that it can be utilized anytime by anyone, anywhere. And then finally, we do have this great unique technology. We're reducing the subjectivity of reading and interpreting results. We're removing those potential issues with color, turbidity, and particulate. It has great advantage in a number of applications, and it creates real value in laboratories and also elsewhere. And I thank you for your time, and I will hand back to Nigel.
Thank you, Brett. That was a great presentation. So we received a number of questions during the session today, and I'd like to thank all of you who submitted questions, and if others of you have questions, please feel free to enter them now. We'll try to answer all the questions, but if we don't get to your question live today, we will follow up with you after this session. So, got a question here from Karishma. It's basically saying, can you open the device if an analysis is complete for one sample and not the other, or do you have to wait for the analysis to be complete for all samples?
It's a really, really good question, and it's a great advantage that I wish I'd pointed out a little more clearly. You can start samples while other samples are currently being analysed. So you could set up one sample at 3 o'clock in the afternoon, and at 5 o'clock another sample comes in. You can process that sample, open the device, insert the cartridge, and start a second analysis. They're all being analysed and incubated independent of each other. The only caveat is that the lid of the device can only be opened for a maximum of 3 minutes before sample analysis is terminated because of a drop in temperature. But typically it takes about 10 seconds to add a sample cartridge. So that should never be a problem. Great question.
Thank you, Brett. So another question here, how many tests can be run at the same time?
So it very much depends. With the B4, the maximum would be 4, but let's consider the B16. If you were running tests all at the same temperature, you could run 16 tests at maximum. If you want to run tests at different temperatures, it will depend on the combination that you want to run. So if you were running a total coliform and E. coli test, that quadrant of 4 samples can then only be run at 35 degrees. If you wanted to run at the same time an enterococcus test, the device, the instrument would select a separate quadrant, and you could run up to 4 at that temperature. So it's anywhere between 4 and 16 samples, depending on the combination of tests and temperatures that you want to run. And I'm happy to explore those combinations with you at another time.
Okay, thank you, Brett. So, question here from Amy. So, if you're using this device remotely with no internet connection, would you have to save the info onto a USB, or would the device be able to store the information until it was required to be recalled?
So all of the analysis reports are automatically stored on the device itself, and the storage capacity is quite significant. I think you need to be running a full batch of 16 samples per day for 4 years before the memory would become completely full. And it will indicate when it's down to 10% and then it's completely full. In addition to that, you could download those reports to a USB device, but they're not removed from the device itself. They continue to be stored on the device itself. So you would then have 2 copies, essentially, of those reports. If you want to use the email functionality, then you would need some sort of networking capability for sure, but not essential.
Thank you. So a question from Elton. Is this confined to labs, or can it be used in remote analysis and treatment service?
Yeah, it's not confined to laboratories. In fact, earlier this week, I was at a wastewater treatment plant where they just have a room, very basic room, where they've set up a detector, and they're going to start running various analyses, both for the plant and also some of the local water courses. So it doesn't have to be a fully fledged accredited laboratory to be able to employ the detector device itself.
Okay, so once a water sample has been added to the cartridge, when must it be inserted into the instrument?
Okay, so we would typically ask that sample analysis within the instrument is commenced within 1 hour of sample preparation. And that's plenty of time for a full suite of 16 samples. Probably takes maybe 20, maximum 30 minutes to process a full batch of 16 samples. And so you're going to be well within 1 hour before starting sample analysis.
Thank you. And what type of maintenance is required for the B16 and the B4?
It's very basic and pretty much in line with anything that's currently done within analytical laboratories. So we recommend that the device is kept clean, and there are specific cleaning agents that we recommend to maintain that cleanliness of the device, and that's standard within microbiology. There are optical covers that we recommend are cleaned with non-abrasive substances. If they do get damaged or scratched, they can be very, very easily replaced. It's not a problem. In addition to that, we recommend the optical validation on a monthly basis, which would take typically around 30 minutes for the full 16 chambers. So very basic, and it's very, very easy to learn.
Thank you. A question from Colin. Do the cartridges have a storage shelf life?
They do have a shelf life. Currently, the shelf life is up to 12 months, and we will never really supply product to an end user that has a shelf life shorter than 6 months. Storage is non-refrigerated, but we do recommend that they're kept in a cool, dry space.
Thank you. So do I have to wait at the full 18 hours to get a quantitative result once the target organism is found?
No. So again, it all comes back to this concept of the higher the bacterial concentration, the faster the time to detection. For a negative result, you would have to wait the full 18 hours. But soon as a positive result is determined by the instrument, sample analysis will stop, and the report will be emailed directly to the analyst, or it will be at least visible on the instrument if there's no Wi-Fi connectivity.
Thank you. So what happens if a test is in progress and there's a loss of power?
So we recommend that device is backed up by a UPS, an uninterruptible power supply, and that should cover the analysis for up to 2 hours. So small losses in power should not be an issue. If there is a complete loss of power, sample analysis will be terminated after 3 minutes.
Okay, thank you. Can you use the Tetra cartridges to collect samples in the field?
We do not recommend that, no. So the cartridges contain the reagent and sodium thiosulfate to neutralize any chlorine, chloramine, bromine that might be in the samples. But we don't recommend that they are used to collect samples, because we do recommend that the analysis is commenced within 1 hour of introducing the sample to the cartridge itself. If there was a scenario where you had a mobile unit, which we do have some users that are employing these on a mobile basis, they are collecting samples in the cartridge, but they immediately go into the device and analysis is commenced. So we can discuss those types of scenarios offline as well.
Okay. So next question, are the Tetra cartridges recyclable?
They are recyclable. The polypropylene is recyclable. It does have a recycling mark on it. The only difficulty, as with majority of microbiological methods, is going through the decontamination prior to recycling. So we would have to explore that particular scenario in various regions on a differential basis.
Question here from Clifford. Is it only applicable to water H2O samples? What about other liquid samples? For example, food, cosmetics, chemicals, etc.
If you are testing those other types of matrix for these parameters, so total coliforms, E. coli, Enterococci, they could well be applicable. again, because of the advantages of the polymer partition element, because colour and particulate don't typically affect performance, they may well be applicable. We'd have to look at that on a case-by-case basis, I believe. We do know of customers that are looking at sediments. So in a similar way to which biosolids are being analysed, they're looking at sediments from beaches and from rivers, resuspending those complex matrices in a liquid sample and then performing the analysis. So I would say with some caution, yes, they could be applicable, but let's look at that on a case-by-case basis.
Thank you. And a question from Frederick. Can we have the results online even if the analysis is not finished?
So the report is only generated and emailed once the analysis is completed. However, if you were in the laboratory next to the device, you can get a progress update just by clicking the sample icons. So you can look at the progress of the analysis in real time, but you would have to be present for that. It's not emailed continuously on that basis.
And then another question from Frederick. Do we need an air-conditioned space to store Tecta?
It's not 100% essential. There are some environmental conditions associated with the use of the device, and I can happily share those with you from the specifications given in the user manual. But it doesn't necessarily have to be air conditioned. I would say that if the temperature, the ambient temperature is, for example, greater than 35 degrees and you're running the total coliform test at 35 degrees, that could be a performance issue because the device only heats, it does not cool. So there will be some situations and some environmental requirements. And again, we can look at that on a case-by-case basis.
Thank you. And a question from Tai Kim. Does the time to detection depend on bacterial concentration or the kind of bacteria like E. coli and enterococci?
It would be both of those. So it would depend on the bacterial concentration, but also the growth rate of that specific target bacterium. But the way this is being developed is that we take samples with known bacterial concentrations and we look at the time to detection for those bacterial concentrations and then create the algorithm that will then convert the relative time to detection to the estimated bacterial count. And that's done over a wide log range so that we can have very accurate algorithms in the instrument itself. So good question, both of those.
Brett, thank you very much. But it looks like we're almost out of time for today. So that's an excellent presentation, Brett, and thank you for taking time to share your expertise with all of us. And also thank you to Clint, Sarah, Nancy, and Pam for organizing the questions and for keeping things running smoothly behind the scenes. I'm very grateful for that. And most importantly, thank you all for taking time to join us today. We know you're very busy and we appreciate you taking time out of your day to attend this webinar. If you've not already done so and are interested, you can download a copy of the slides in the Handouts tab. While you're in the Handouts tab, you'll also see other resources available for download. So you can visit idexx.co.uk/water/education to see upcoming webinars, new and featured courses on the IDEXX Water Academy and read IDEXX Currents articles. The IDEXX Water Academy contains many online courses, videos, micro-learning content and other resources about this topic and many others. The Water Academy is completely free and available at any time. If you haven't signed up yet, we encourage you to do so. Instructions to register for the IDEXX Water Academy are in the Handouts tab. I'd also encourage you to visit IDEXX Currents, where you will find many articles about trends in the industry that will help you remain current on industry developments and the latest news. Our next webinar is part of the European Union's Green Week. The webinar is entitled The New Urban Wastewater Treatment Directive, a summary and technical update. And this is on Wednesday, the 3rd of July, at 1400 British Summer Time, 1500 Central European Time. If you have a question after the session, or you're watching the on-demand version of this webinar, feel free to contact us at wateruk@idexx.com, and one of our technical service people will follow up with you. So thank you again for your time and participation in today's session. We look forward to seeing you again at a future IDEXX webinar. Take care, everyone.